.10, it says right on it.
Okay.
So it's a tighter tolerance. So you got to check the low temperature and the high temperature, make sure the calibration probe is fine. And if that's not reading correctly, recalibrate it. First course of action. Still not reading correctly, it's going to be a replacement. It used to be this had a plug, and this could be simply unplugged. And you may have, most of the models you see out there may have the plug in it. But they have since, in the past several years, it's only been out for 10, but for the past like 3 years now, they've been changing it and hardwiring it into the harness. So it's not simply, if this is not reading correctly, it used to be you would change the probe out. First course of action would you do a calibration, recalibrate it, make sure that it's checking fine. If it's not holding temperature again, it's going to either be in this harness or it's going to be that A to D converter board that we talked about. That's an analog to digital converter board. There'll be something on there. A lot of times, troubleshooting wise, and this is a good troubleshooting point, a lot of times on the board here, I got everything running, so I don't want to take anything apart. But these right here, these are all your wires for going to every one of the RTDs. This is one is the first one, two is the second set, third, fourth, the fifth, and sixth on this connector right here. And the red, black, and white wires over here at the end are the ones that are going out to this probe here. Sometimes these pins have a tendency to unlock and push back a little bit and not make really good contact. And that could be a source of temperature fluctuations also. So that would also be something that you might want to check. If you're getting some inconsistent temperatures, along with a lot of other things, you know, the slip rings, the wiring going to the connector on the slip ring, the harness itself. But I mean, this is again another source. First and foremost, any temperature problem that you have, whether it be with the probe or with the RTDs, do a temperature calibration, just to make sure that you don't have something that's out of whack. That would be the first thing I would look into. If you're consistently getting a problem, you can see right off the bat. If it was reading 101, usually that indicates a bad slip ring and or a wire going to the connector that's up on top of it. We'll take this apart and I'll show you how that looks up inside there in a second.
With the wiring inside the shaft is broken.
Well, the shaft would be just replacing the shaft. But the troubleshooting wise, the easy way to check that is just to simply take the connector off of this one and put it on this one and vice versa. And you can see whether the problem reverses. If it stays with it, then obviously it's with the wiring or the connector. But if it changes, then obviously, you know what, you got a problem with the shaft or the slip ring. That's the easiest way to troubleshoot it. Going forward, okay, again, like I said, the probe has to be checked at low temperature between 15 and 25 and high temperature between 35 and 40. That's the external probe. And then we get to actually making all the measurements. I don't know how familiar you are with all the measurements and how to make them, but we'll start off and we're going to do centering right off the bat.
Make the mercury inside. All over.
Yeah, there's some mercury inside.
What is the average time that it takes to do a complete PM?
What's the average time? Average time or my time? I mean, it's different. We've had this argument already because I wrote up a new standard here for our inside techs on how long it takes people to do things. And some of the people weren't happy with the numbers that I was putting down there. It typically takes me, I can go out and do a PM MQ on a unit and the documentation and everything else between 2.5 and 3 hours. So I usually can do 2 to 3 units a day. Some of our technicians are, oh, I need 4 hours, I need 5 hours, I need 6 hours. Oh, okay, well, then that's, you know, but typically it takes me, I just get in front of the unit and I just work, and I just do it. And then, so it takes me typically 2.5, yeah, I'm here, when I'm on the field, I want to get my job done and I want to go home. I'm sorry, I just want to do my job, go home, go have a beer, I'm happy. So again, 2.5 to 3 hours is probably my average. But I would say probably for most technicians, the average of doing this is probably 4 hours per unit. I would say that's probably a good rule of thumb. And if anybody's not making the 4 hours, that's probably a good average for them to shoot for. Any new technicians, when you're telling them, when you're training, if you have to pass on your training to somebody else, tell them that 4 hours is probably a good average to shoot for. Because that's getting down to where you can probably do about 2 a day. That's the regular mechanical qualifications, meaning, and that's if there's no issues and problems that crop up. Obviously, if there's any troubleshooting involved and something breaks or something is out of tolerance or out of specification, you're going to spend some extra time doing some troubleshooting.
You know, the guys in the TIVA, they wrote protocol after yours, but you must check every 5 minutes every vessel, so you have 1 hour of just measuring.
Some people go overboard with it. I mean, just
You have to see if the temperature is stable.
right, but again, that's the purpose of the 30-minute test. Beginning of the test, it's one temperature. The end of the test, it's the one temperature. It should have maintained it throughout the run. You should have gotten that normal heating profile, but it stopped any time in between.
Okay, they can pay us €2,000 more per machine, and I will buy an additional 5 probes and put them in.
Put them
and
all at the same time?
I can do a 24-hour test.
We've had some people that paid extra money. We've had some laboratories here in the United States that wanted us to do 24-hour. There was one lab down in Georgia that wanted us to do 72-hour testing on temperature.
Okay,
We had to
just
buy
program
special.
in the logger for 70.
Well, we had to program. We had to get special programmable thermometers, temperatures that actually had printers attached to them that would print out the temperature of every hour.
Hey, are those vessels get warmer than those because they are closer to the
Typically, no.
water?
Typically, it has a
There
tendency to
shouldn't be
shrink.
any.
It shouldn't be, but there is some minor temperature
Difference.
changes that you will see at times. Usually, overall, it'll adjust it, but I mean, again, this is a bath unit, so obviously,
I saw the first two are a bit colder or not, and this here is actually the hottest, and this one.
but you're talking,
Because-
usually when it happens, you're talking,
0 point something.
yeah, 0.5 to 0.5 to, I should say 0.05 to 0.1 variation typically. That's the most you're gonna see. That's not true though, however, folks, on this model right here, the difference they found. I don't know if they changed the pitch on this here. We can talk about this at a later date. You don't see it so much happening with the 6 positions on the 2500s. I don't know how many people work on the 2500s, but we've had some issues with 7 and 8 position 2500s. To the way this comes out, for some reason, when the water comes out of this upper one right here, it's shoot. I guess the angle is coming in here because this is a little bit more robust, so it pumps the water a little bit faster. Not remarkably faster than the old TCS, but a little bit faster. And because it pumps it a little bit faster, they found that it's hitting inside here and it's causing the media to go off at an angle over here when it comes out. And when it's going off at an angle, when you have a position here and or 2 positions here, 6th, 7th, and an 8th position, it's hitting it and bouncing it back over this way. And we've noticed that we've had some temperature differences on this one right here.
That's higher than the others?
It causes a temperature degradation in here, and it also causes additional wobble in this one. Our results for chemical testing always seem to be different on this end than down at that end over there. Very minor, not failing, but there are some differences. So if you do encounter any problems with 2500, if you have a 7th or 8th position 2500, that's something to bear in mind, that maybe perhaps the circulation in it has changed. What can you do to fix it? I don't know. They're still trying to figure it out. They're actually doing mapping of how the system is circulating the water around right now. So they're trying to come up with some ideas on how to adjust that. It might be simply just putting a matter of putting a deflector on as it where it comes out. Varian does it with theirs. They have like a little wire screen on their bass when it comes out of it. So when it hits against it, it deflects it to the bottom. But we got to make sure that that thoroughly still circulates the media around to where all the temperature stays the same. But again, on that one over there, very minor changes between one and the other. This one here, maybe a little bit more because of the issue that we've seen. But we'll get to that when we start working on that one. Centering. As indicated before, when we talked about how to go about doing centering, get this one out of the way so you can see what I'm doing. Why this is jammed up so much? What am I hitting?
No problem.
25. So you want within 2 centimeters of the top. And you want to do your reading. So now you can see the deflection on here. And the deflection on this one, I would probably put down 0.25. I only see one. It's going from the line to the dot, which would be 0.5. Cut in half is 0.25.
But we measure 2 centimeters from the top and 2 centimeters
From the top of this, yes, top of this, within 2 centimeters of the top,
And 2 centimeters,
and 2 centimeters above the apparatus.
above the-
It's on the bottom. So typically, I'll just slide this down. If you slide it down to a little bit below 500, that's usually about where it needs to go. And then do the same thing reading down inside there, as you can see. And that one's probably 0.5, it looks like. Looks like about a 1 millimeter
No,
deflection.
it's 1 millimeter more.
So cut in half, that would be 0.5. So any reading you get off of that, as I indicated yesterday,
from a dot.
that tells you maximum deflection. The reason you cut it in half is because you're reading from the center point. So you're reading one side, and then you're also reading the other side. And whatever that deflection is, you have to cut it in half because of that way that reads it, so that it's divided by 2. That's a 1 millimeter deflection right now that I'm seeing, so cut that in half. I would put down in the document 0.50.
So this is the proper way. I usually do this, like
You can raise it, or you can raise it by hand.
yeah. I usually do this. I put it here, 1 centimeter above, and then I go up and down.
You can.
This
can
is
do that.
also correct. Yeah?
That's correct.
Yeah.
I just saying, typically what I do is, when I'm going around doing it, is I'll attach it in here, within 2 centimeters, so that I can make my reading. So then I do my upper reading, right on here, centering top, and then I'll simply just push it down. And then take your reading.
So they both are correct, like
Yep.
this and this.
So how do you put it on?
As long as you're within 2 centimeters of the top of the apparatus.
Okay.
Do the clips make any difference if they're tighter or loosening?
Not generally, as long as you've already inspected it during the PM. Typically, you'll do a PM before you do an MQ. They need to be adjusted properly, as we went through before. And I mean, they're supposed to hold the
Yeah.
system
Yeah, just
down.
make it stay with the.
They're not.
Yeah,
they don't
always
need to
be careful
over-tightened
not to
where
break
they're
that tip,
compressing
like
it down
if
when they're
you
holding it. I mean, you can,
do this,
but I mean,
just-
a lot of labs
Yeah,
like to do
don't
that. A lot of the
push it
analysts,
hard,
when
like.
the scientists in the lab will tighten them down so
Otherwise,
that they can get them.
it's easy to
That's not
break
the
the
proper
slip.
way to use it, but
And
they
then it's
can.
problem to take out
That's part of
the
explanation,
leftover,
that
in
if you
the
over-tighten it, you
trick.
can tilt the
You can,
vessel,
you can tilt
and
it.
it
Yeah,
will
so
not set.
2
But
centimeters.
the centering ring in here, that's actually what's centering the unit. So most of the scientists need to understand that when this thing's filled with water, there's buoyancy. And the only reason these clips are here is to stop the buoyancy from pushing the vessel up and out of there. Once you actually fill it with 500 milliliters or 900 milliliters or even a 1 liter worth of media and do any kind of chemical testing, it's going to settle down even more. So that's all that ring is there for. That's to center it, and these clips are just to hold it down so that it doesn't go flying off anywhere. So again, it doesn't need to be over tightened. Like I said, we adjusted these, so these are all fine. So that's the centering. Now, what to do if it's out of centering? Let me adjust one that's out, so I can show you.